Hello, welcome back to our little corner on the web, where we aim to nurture both the interest and knowledge of learners in math. In this video, we will share one way to solve question 18 in part 1 of the 26th Philippine Math Olympiad area stage. Again, thank you to the organizers for freely sharing their questions online. We hope that you will find this useful and educational. Question 18 states that if x is an irrational number and k is an integer such that x to the 14 plus kx and x cubed plus 2x squared and x squared plus x are all rational numbers, what is the value of k? Okay, so first thing to note, if x is a rational number where we can make it rational by raising it to some powers or some combination of powers, then it cannot be a transcendental number. That means that we can go back to a sort of generic form of an irrational number, right? Which is of the form a plus b root c, where a, b, and c are all rational numbers. So if we let x be equal to a plus b root c, we can sort of try to find such an irrational number that might work for all three of the expressions that were given. So the first thing is we'll use x squared plus x to find some of the unknowns, if possible, and then work ourselves up. Okay, so if x squared plus x is a rational number, then we can find x squared by squaring our expression, and we will get a squared plus b squared c plus 2ab root c. If x squared plus x is rational, that means the term with root c from x squared and x has to cancel each other. Said in a different way, 2ab root c plus b root c has to equal 0. Okay? Since we know that a, b, and c are rational numbers that are not 0, right? Then we can sort of cancel each other out. The b root c, we can divide both sides by b root c and end up with a is equals to negative a half. Or one form of the expression becomes x is equals to negative a half plus b root c. Okay, so now let's use x cubed plus 2x squared to sort of help hopefully find b root c. We can express x cubed plus 2x squared now as the expanded form of our new x, right? Or the recently found x. So x cubed plus 2x squared is no more than negative 1a plus 3b root c over 4 minus 3b squared c over 2 plus b cubed c root c. This is nothing more than the expansion, using binomial theorem or just Pascal's triangle of x cubed. And then we have twice of x squared. Twice of x squared is no more than 1/2 minus 2b root c plus 2b squared c. Again, for this expression to be rational, the terms with root c has to cancel each other out. Right? This means that the 3b root c over 4 plus b cubed c root c and this negative 2b root c has to equal 0. Okay. Again, some manipulation canceling out or dividing by root c and b, we end up that b squared c is just 5/4. Taking the square root of both sides, we have b root c is actually plus or minus square root of 5 over 2. Okay, so our expression now, our whole expression for x is already found, which is x can be equal to negative a half plus minus square root of 5 over 2. Okay. For our purposes, we only need one of them, and we'll leave it to the viewer to prove the other one if you really want to. We'll take one of these forms and try to generate an x to the 14 plus kx. Okay, so if we take the positive form of the root 5 over 2, we have x is simply equal to -1/2 plus root 5 over 2. So our first instinct might be to say x to the 14th, let's use the binomials theorem, okay? But once you start writing it out, you would realize this expression looks very, very ugly. It's not impossible, but it looks fairly ugly to be able to expand this and keep carelessness to a minimum. So since this looks ugly, the question is there a faster, or if not faster, is there a way for us to generate x to the 14 without necessarily, being at the mercy of our carelessness? So it turns out that this form of a binomial, if we just keep raising the power slowly, we can keep simplifying it to another binomial. So what do we mean by this? So we first take x, we take the square of it, and we keep squaring until a certain point that we multiply different powers of x. So first, we take original x, square it. So that's just a square of binomial. So we have -1/4 minus root 5 over 2 plus 5/4. We simplify that into 3/2 minus root 5 over 2. Now this is a very easy expression to manipulate again. We can square this to end up with an x to the 4th. So our x to the 4th now can be simplified to 7/2 minus 3 root 5 over 2. Again, we're not doing anything that's different from a plus b quantity squared. Okay. So now that we have x to the 4th, we will try to generate x to the 6th and hopefully x to the 7th, which we can just then square. So x to the 6th we generate by just multiplying x to the 4th and x squared. Okay. So we end up with 21 over 4, which is the product of the first terms, 9 root 5 over 4, which is the product of the second term of x to the 4th and the first term in x squared, minus 7 root 5 over 4, plus 15 over 4. Again, we can simplify this now into 9 minus 4 root 5. Okay. Multiplying x to the 6th to x, we end up with x to the 7. Okay. And squaring x to the 7, we end up with an expression for x to the 14. In reality, we only needed to solve for the irrational part of x to the 14. So now, if x to the 14 plus kx is rational, that means that kx, the irrational portion of kx, has to cancel -377 root 5 over 2. Okay, the irrational portion of x is root 5 over 2. So that means that k times root 5 over 2, when added to -377 root 5 over 2, has to equal 0. That means that k has to be 377. Hopefully you found this video useful and educational, and hopefully you learned a trick or two. If you found this useful, please do hit the like button and subscribe. Thank you for watching.